All right, so chapter 2, lesson 5, modeling real-world data using scatter plots. So what we're going to learn in this lesson is we're going to learn how to draw scatter plots and how to find and use prediction equations. So some of the vocabulary is going to be scatter plot, line of fit, prediction equation. And so as we look at these scatter plots, just understanding that in order to model data with a function, it's helpful to graph the data, right? And this set of data that's graphed as ordered pairs in a coordinate plane is called a scatter plot. So a scatter plot can show whether something has a relationship between the data. Let's try to look at an example. So if I were asked to draw a scatter plot, I'm going to go ahead and I am going to uh, first look at this example. It says the table below shows the median selling price of new privately owned and one family houses for some recent years. So it says make a scatter plot of the data. So here I have my data points, right? So I have the year and the price, right? Going through here. So these are going to be treated kind of like coordinate points, right? So one's going to be an x value and one's going to be a y value. Typically, when we're choosing coordinates, typically time is going to be our x value. So this will be my x value, this will be my y value. So in order to graph the data as ordered pairs, I'm going to use my x to be the year since 1990. So this will be 0, 2, 4, 6, 8, 10. And that's going to be my horizontal x-axis. And then the price is going to be the vertical axis, right? The cost in thousands of dollars. So here's the price. Here's the years since 1990, right? So 1990, 92, 94, 96, 98, 2000, right? Because these are years since 1990. And so 1990, it was 122.9 thousand, right? Here in 1992 was 121.5 thousand, and so on and so forth. So these data points right here are just these coordinates from the table, right? So this would be an example of a scatter plot because it's not graphing a line, it's graphing data points. So one thing to kind of keep in mind as you're going through this is typically letting x be the number of years, right? Having to be the time is a lot of times will be helping you simplify any calculations we have to do in order to find certain values for the function when we're trying to model this data. So um, prediction equations. So except for 0, 122.9 in the data in example number 1 appear to lie nearly on a straight line. When you find the line that closely approximates a set of data, you are finding the line of fit for that data. So basically, a line of fit is the line that most matches up with your data, because a lot of data sometimes won't match up perfectly. It doesn't create a perfectly straight line. So a line of fit would be what matches, what fits the best. An equation of such a line is often called a prediction equation because it's the equation of that line that most likely will predict the pattern of behavior for that data. Because it can be used to find one of the variables given another variable. So to find a line of fit and prediction equation for a set of data, typically you select 2 points that appear on the line and then use those 2 data points to help you come up with an equation, just like we've done in previous lessons. So line of best fit in a prediction equation can vary from person to person, depending on what 2 points you pick. You always want to try to pick the 2 points that kind of best fit the pattern of the data. So let's look at our problem here. So I've taken the data from our example number 1 there. So we're going to refer to this data here, and we're going to find and use a prediction equation. So there's several parts to this. First, we're going to draw a line of fit for the data and see how well does the line fit the data. And then we're going to find a prediction equation for that line. And we're going to answer what does the slope and the y-intercept indicate. And then we're going to predict the median price in 2010, which would be 20 years out after 1990, which would be like way over here on our, probably more likely way over here in our graph. And then part D says, how accurate is the prediction? So let's go ahead and take a look. One thing to also recognize is anytime you have a data point that doesn't appear to belong with the rest of the set, it's called an outlier. So if you look at these, they all kind of follow along pretty well, except for this guy. This guy kind of doesn't, you would kind of imagine that it would fall more down here. So this is maybe something you might consider to be an outlier. So part A, drawing a line of fit for the data and how well does it fit the data. So if I was looking at this data right here, I'm probably gonna draw a line that looks, so probably ignoring this one right here, right? And probably looking at the points here where I could say like maybe between this point and this point, probably splits the difference of all these lines. So I'm gonna go ahead and I'm gonna draw a line through kind of these 2 points here. And if you see, I get some points below the line, some points above the line. These two kind of are right in the middle. And this one's the only one that we kind of called an outlier that kind of falls outside of that. So this is a good representation of a line of fit. Now yours might look a little different, but this is just the one that I chose that kind of seemed to fit pretty well. So let's go ahead and find a prediction equation, right? So first thing, if I pick these 2 points here, these are the 2 points that I'm going to use for my prediction equation. So let's go ahead and first thing I'm going to do is I'm going to use my slope formula, and I'm going to use the 2 points that I chose for my data set as my 2 starting points. And then I find the slope between those 2 points. And remember the 2 points that I picked were 4 and 130 and 8 and 152.5. Right? So the slope is approximately 5.63. So now that I have my slope, I'll use my point slope form, right? I'll put my slope in, and I just have to pick one of the x and y coordinates. So I'm going to go ahead and pick this one right here, 4 and 130. And then I substitute all my values in. Now I just have to simplify, right? So 5.63 times x is 5.63x. 5.6 times 3 times 4 is 22.52. And then I add 130 to each side, and I get y equals 5.63x plus 107.48. So now this is my prediction equation, right? Because this is the equation that represents that line of best fit that I drew on the graph. So what does the slope indicate? The slope indicates that the median price is increasing at a rate of $5,630 per year. Because remember, this is in thousands of dollars, right? And the y-intercept represents what the kind of starting value at 1990, right? That's my y-intercept, represents where does it start when x is 0. So that means the starting price would be at $107,480. Let's look at part C now. We're going to predict the median price in 2010. So remember that in 2010, that's 20 years after 1990. So my x value is going to be represented by 20. So I'm going to use my prediction equation, and I'm going to substitute in the value of 20 in for x. I'm going to multiply it, and it's going to give me multiply and add, and that's going to give me 220.08. So that means that my median price in 2010 would be $220,080, or approximately $220,000. Because remember, this is in thousands of dollars. So if you multiply it by 1,000, that would give you this value right here. So taking a look here, it would make sense that my prediction in 10 years after here, right, and 20 years after 1990, it's going to be somewhere over here, right? So that kind of makes sense with what's going on there. And it says, how accurate is the prediction? Except for this outlier here, I would say that my predictions look pretty spot on. So I would suggest, I would assume that it would predict the value fairly accurately if these trends continue in this fashion. So when you're using your prediction equation for a specific x value outside of your data set, so this is my data set. Since I picked a value that was way outside of my data set, that's what's known as extrapolation. So I use my prediction equation to extrapolate that pattern, right? If I picked an x value inside, say I picked 7 years after 1990, right? This is inside of my data set. This is known as interpolation, right? Because you're doing inside of your actual data set versus if you're doing something outside of your data set, it's called extrapolation. So in part C, we did extrapolation, but if we were to pick some sort of x value between 0 and 10, it would be known as interpolation. All right, let me know if you guys have any questions. Thanks.